All right, good afternoon, ladies and gentlemen. We're going to be working today with 6.6 inverse trig functions. We're going to figure out what they are. Even though we've used them a little bit before, we're going to kind of really use them in this entire section here. And really how to use them. There's more than just the little ways to use them. All right, so first of all, what are they? Really brief. They are the inverses, obviously, of sine, cosine, and tangent. They look like this on your calculator: sine to the -1, cosine -1, tangent -1. However, that's not really -1. That actually indicates inverse for us. And it always has. Back when we were dealing with functions, we looked at function notation being f of x. Its inverse was f inverse, like this. So to us, when we deal with a function, that little -1 does not really mean an exponent, but rather means inverse. Now, one of the ways to kind of eliminate that confusion is the other way that inverse functions are written, and it's written like this: arc sine, arc cosine, or arc tangent. But what you need to know is those things are exactly the same. This particular textbook likes to use arc sine, arc cosine, arc tangent a lot, and I think engineers use this terminology a lot more frequently than they do with the -1s, just to not confuse the matter. But this first line here, sine with these -1s, that's what's on your calculator. This is more than likely what's going to be seen a lot in your textbook. All right, so that's what they are. I'm going to kind of use how to use them with a little bit of more definition of what they are. The inverse trig functions are the functions that undo their counterparts. So they undo each other. And it's basically the statement here: the sine inverse of sine of x is equal to x, just like the square root of x squared is equal to x, because the square root and the square are inverses of one another, and therefore they undo each other. So, and I like to use this example because we've done this plenty. So, or we'll get to that in a second. But they're used to solve for angles of triangles, and they're also used to solve equations coming up in the next chapter. What we're going to be basically doing is solving word problems in the next section with triangles, but we need to know the angles. We need to solve for the angles. Now, we use these, just like I mentioned a second ago, we use these like we use square roots to undo squares. So if we had this example from Algebra 1, I would think, really. So we would add 1 to both sides. Oops, equals. Sorry, let's try that again. 9x squared equals 1. X squared is equal to 1 over 9. X is equal to 1/3. And technically we have plus or minus because there's 2 answers to this. And there actually will eventually be 2 answers for us in trigonometry, but that's for a later date. So if I was to take this sine of x is equal to 0.3, I would take the sine inverse of both sides as I did with the square root. So I would take the sine inverse. Now this is something you don't always have to write here. We just know they undo each other. And this cancels to an x. And if I plug into my calculator, if I plug in the calculator the sine inverse of 0.3, I get 17.46 degrees. All right, so the process is not hard. That 0.3 could have actually been written as, and we're going to see this a little bit later, it could have actually been written as 3 over 10, like ratios of sides of a triangle, which we will be using. Some of our questions will be the ones that don't require calculators, and that would look something like this, where I said the sine of x is equal to 0.5. Well, if you were to think about your circle, your unit circle, the sine is equal to the y coordinate. Well, there's a y coordinate right here. This is root 3 over 2 comma 1/2. there is a y-coordinate that gets me 1/2, which means my answer here, x is 30 degrees. And basically the question is, what angle, the sine of what angle equals 0.5? It's the same question up here with the 0.3. The sine of what angle equals 0.3? Well, there's no special angle that makes that statement, but there is one for the 0.5. Likewise, the cosine of x is equal to 2. This is actually a non-calculated question. You can do it in your calculator, and you could do the first one in your calculator, but we should start getting this understanding of, if we were to, oops, that's not a cosine function. If we were to graph a cosine function or a sine function, the only outcomes that we get are between -1 and 1. So there's nowhere on this graph, there are no angles that will reach a value of 2. So this one is actually, we like to use D and E, does not exist. Or if you plug that in your calculator, you get an error. So some of these where we get special numbers are ones we don't need calculators for, or if the number is bigger than 1. So if I was to say, hey, the cosine of, or sine, whatever, the cosine of what angle is equal to 1.1? Well, that's bigger than 1, and it doesn't work. It doesn't work for sine and cosine. Tangent's different. Tangent has its own set of rules, just like before. Whereas, as we just kind of looked at that previous example, sine of x equals 0.3, you would take the sine inverse of both sides, and you would get that 17.46 degrees. All right, so it's a pretty easy function to begin to use. All the inverse functions are. So you notice I was getting 17.46 degrees as my answer. So a lot of people will ask, what mode should we be using when we do these problems? Well, that depends. Do you want a degree as your answer? Well, in most real-world problems, we're going to use degrees over radians. Radians are nicer to use in just the math of things. So if you want a degree as your answer, you should be in degree mode. However, if you want a radian as your answer, let's say the question asks for what's the radian measure of x, all you have to do is change your calculator radian mode, redo the cosine inverse. So if I went back to that particular problem and I said, let's do the cosine inverse of sine inverse of 0.3, but let's change it to radians. I get, so if I said, hey, cosine of x equals 0.3, x is equal to 0.3, let's go 3 decimals out, 36 radians. Whereas if I did it in degree mode, I get 17.46 degrees. So you could probably figure out that 17.46 is equal to 0.336 radians. All right, so it depends on what your calculator is in or what you want as an answer to determine what mode you need to be in. I'm not going to do this example because we did this one with the 0.3 instead. Now, we're going to end up solving triangles, as I mentioned before. So the question is, how are we going to use them with triangles? So what we need to do is you may remember this from geometry actually. You need to set up the trigonometric ratio according to the given information. And then just simply solve for x. Or in most cases, this x will actually be a theta because we're dealing with an angle. So if I gave you this, some of our problems are going to give you triangles. That's an ugly triangle. I'll try again. Now, we can only deal with right triangles right now. And let's say theta's here, and they give you 3 and, 7. Well, according to theta, you have the opposite and hypotenuse. That means sine of theta is equal to 3/7. Stuff we've done before, but now we want to know what is theta. Well, theta is going to be the sine inverse of 3/7. sine inverse of 3 divided by 7. Make sure you actually plug it in just like this in your calculator. Make sure you close the parentheses. Sometimes the calculators get confused. I want to be in degree mode because we're dealing with a triangle, and I kind of like angles in degrees here. So theta is equal to 25.38 degrees. So depending on what you have is dependent on what function you're going to use. So let's say this 7 wasn't there, but it was actually here. Well, now I have opposite and adjacent, which doesn't say sine. That says to use tangent. So that means tangent of theta is 3 over 7. So tan inverse of 3 over 7 is actually 23.19, or sorry, 23.20. Okay, so notice the problem didn't become any harder by changing the sides. So all we looked at is here's theta, you have the opposite and the adjacent side, which means tangent. We use tan inverse to solve for the angle, and we're done. But every once in a while they get a little bit harder. And we look at these things called compositions. Now we've done compositions of functions before. This is going to look somewhat similar. What it is basically a combination of two trig functions, or actually in this case what we're doing is a combination of a trig function and an inverse function. And it doesn't matter what's inside, what's outside. The process is still basically the same. So here's our example. Sine of the arctan of 3/4. So again, that's just tan inverse. And here's what we're going to do with this one. We're going to set up a triangle, and we're going to then solve for this answer. Now, if you kind of think about this, arctan of 3/4, that gives me an angle, just like we've been doing before. So this means theta is this thing here, which means that sounds about right because we should be taking the sine of an angle. Okay, well, that means I can set up this triangle. I can put theta wherever I want, just not the right angle. And according to theta, if this particular property right here, I didn't actually mention this, goes in both directions. If theta is equal to the arctan of 3/4, that means the tangent of theta is equal to 3 over 4, which means we can put on here the opposite side, which is 3, the adjacent side, which is 4, because tangent is opposite over adjacent. We have 3 over 4. Well, that's kind of nice because that means I can do the sine of theta. So now we're looking at the sine of theta. Well, theta is opposite over hypotenuse, so we need to find the hypotenuse. And if you're clever, you remember that 3, 4, and 5 make a Pythagorean triple, which means that 5 there's my hypotenuse. You can check that with Pythagorean theorem. So this means that the sine of theta is 3 over 5. Oops, and then I wrote a 4. 3 over 5, and your answer is 3/5, or 0.6. Okay, you do have to do this way. There's really not a lot of ways to go around this particular process. So let's try again. Let's go to sine of arctan of x. Now this makes it a little bit more challenging is because we have a variable instead of a number, but the process is still the same. We're going to draw a triangle. So now we have theta is equal to tan inverse of x, which means the tangent of x is the tangent of theta is equal to x over 1. So we put our theta in here. Tangent is opposite over adjacent. Oh, now I don't know how to, well, this is just a number, and this is a hypotenuse. So we can find the hypotenuse of a right triangle by taking the square root of the squares, or the sum of the squares of the other two sides. Pythagorean theorem, really. We get x squared plus 1 squared, which is 1. So then we're finding the sine of theta. Sine of theta is going to be opposite over hypotenuse. And in this case, it's opposites x. Hypotenuse is another function. And there we actually have our answer. There is no numerical answer for this particular question because it started off as a variable or as a function, so our answer is going to be a function. All right, so I hope this has helped you a little bit. We're going to spend 2 days on this, make sure we fully understand every aspect of inverse functions. There are a couple little things that I'm not going to be discussing. I think I left them out of your assignment, but we'll see come Tuesday. What I do have here is, though, kind of an outline for the next 2 weeks, just so you guys are well informed. We will be working on 6.7 Tuesday and Wednesday, or Tuesday and Thursday, depending on your class. 6.8 will be Friday and Tuesday, because there's no school Monday. I will get the video for that for shortly, because it won't take very long. All it will be are examples of the word problems, because this is a fully word problem section, kind of good examples of where trig is used in the real world. Review, there might be a quiz in here, I forgot about that, right around 216 or 217, depending on what happens. But I do have the plan for the test next week, Friday. This will cover all 7 sections of Chapter 6, and hopefully you've been studying for the last 5 weeks we've been in this chapter. Hopefully things are starting to click. The next chapter that we're going to be covering, whatever we end up covering for the end of quarter 3, will kind of be a mismatch. I kind of want to throw a little bit of chapter 8 and a little bit of chapter 7 together to finish the quarter off, and then we'll kind of fill in the leftovers into quarter 4. All right, so I will see you guys tomorrow. Have a good evening, and good luck.